let's assume not B. Okay? And then our goal would be to get to not X. Does everybody understand that? Okay, but when we make an assumption, we say assumption for conditional proof. I don't know what abbreviation I used, okay? So you have to say this is an assumption for conditional proof. And since this is an assumption, it's not something that we can say is the case. Does everybody understand that? So we have to say, hey, this thing rests on an assumption that was made in line 3, okay? And any other line that utilizes line 3 will rest on the assumption 3, okay? All right, so my goal is not X, okay? And so I need not one of those, and I can get not one of those by, look at this. I'm gonna do a modus tollens between 2 and 3. And what does that get me? It gets me not Z and X from 2 and 3 modus tollens, right? Now, I used line 3, which means that this actually depends on this assumption. So line 4 also rests on the assumption 3, okay? All right. Now, I'm trying to get not X, okay. This is not exactly the opposite of this. Oh, wait. This is a Y, thank goodness, okay. I'm just going to do a comm on those in there. And so I get not Y and Z from 4 by comm, but I used 4, and 4 depends on 3, so 5 depends on 3 as well, okay? But now look at 5 and 1, I can do a modus tollens, and what do I get? 6, I get not X, right? And so that's from 1 and 5 by modus tollens, okay? I used 5 rests on 3, so 6 rests on 3 as well, okay? But now look what I've shown. I've shown that if you assume B, you can get to not X. So on line 7, I can say, well, if not B, then not X, go see lines 3 through 6 as a conditional proof. Okay, and 7 doesn't rest on an assumption because the proof of 7 is 3 through 6. Everybody understand that? And we're done. Okay, what's really nice about conditional proofs is that it almost gives you an extra premise to work with in some sense. Does everybody understand that? Okay, so I got myself a not B, gave myself a not B, and then the goal was that, and then I could say the conditional must be true. Okay, now you might think that conditional proofs only lend themselves to proving conditionals, but that's not true because they lend themselves to proving any statement that can be converted to a conditional, right? So look, this I know is the same as what? B or not X, right? By implication, right? And this, by De Morgan's going backwards, is equal to not B and X, right? So let's suppose they said, prove this. Well, if I'm clever enough, I would realize this could be converted to that conditional. So I would go about assuming a not B, right? And end up getting to that. And I'm good. Does everybody understand that? So conditional proofs are good for any proof where what you're trying to prove is a conditional or can be converted into a conditional. Does everybody understand that? So they are very powerful. Now, you saw that we noted this, the premises and stuff like that, and these can get very complicated. You may make several assumptions. So it might be that a line depends on assumption that made in 3 and an assumption that's made in 5. So you can have multiple assumptions out here. And this step right here is called discharging the premise or the assumption. And so when you have more than one assumption, if they overlap, you have to discharge them in a particular order and all that kind of stuff. If you're into trying to do these, you want to do very complicated ones, come see me, I'll talk you through that. Otherwise, this is about what you need to know, okay? Okay, so continue working on 5.2, 5.4, and a quiz will be available on Thursday to be due Sunday night for us to go over on Tuesday, and we have next week to continue doing these problems, and then you get your test on Thursday, due Sunday night. All right, that's it for today.